this video, we're going to do most of the wiring to wire together the parts, and then we're going to assemble the body of the robot as well. All right, in the last video, we started assembling the body parts by mounting the motors. What we want to do now, before we do anything else, is label each of these motors. It's important to make sure that the software knows which motor is which, so we're going to label them so we wire them up correctly. We've got little labels. You can cut labels however you want. I've got little dots. I'm going to write the numbers 0 through 10 on each of these and label them. You can see the little numbers right here on the plastic next to the motor. So that's the number we want to label it with. So that's number 7, 6, 5, 4, 3, 2, 0, 1, 0. So we're going to put labels on those. Figure out the orientation you want. I generally orient them that way because they're going to plug into the board like that. This is number 2. So for the other 3 motors, you just have to know from this video which numbers they are. The tail motor is number 8. The neck motor is number 9. So on this assembly, that's the one that's pointing down that spins the neck left to right. So we'll put the number 9 on there. And the head motors, so that's the motor here that's basically tilts the head up and down, is motor number 10. All right, so there's 11 motors. As with most programming, the counting starts at 0. So we label them 0 to 10. Next, we're going to start mounting some boards. Move these aside. You want to find this frame piece here. This is the center body frame piece. A couple of boards mount on this. We're going to put some mounts on here because it's easier to do that now rather than later. This board is symmetrical, so just decide which side is up. We're going to put board mounts in these very far 4 corners here. These are M2 mounts, 6 mils off the base. And it's just easier to do these now. I got this piece open. Once it's inside the robot, these are all kind of hard to reach. All right, so I'm just going to use this little ratchet to help spin these down. Makes life a little easier. I'm also going to put 2 in these holes on the very front. This mounts the accelerometer. Just so we can see, this board will mount here. This is the servo controller board. And then there's another accelerometer the gyroscope that will mount on these front 2. We'll come back to that board in a second. We're now going to mount this little sensor. This is the distance sensor on the front of the robot, used primarily just to keep it from walking off the end of a table. This is a sharp sensor. This is a little 3D printed mount that mounts on the front because I kept changing my mind on which sensors to use. And so I could 3D print different mounts depending on the angle and the size of the sensor. So currently this sensor fits right inside there. And again, it's just easier to mount on this board now on the frame of the robot while the frame is still apart. So I just need to figure out this is the bottom of the mount. I can just use M2 by 6s, right? One of our standard 2 mil bolts that we're using in this kit to mount a little mounter. If you wanted to put blue Loctite on these little bolts, wouldn't hurt. To mount the actual sensor, I'm going to use one of these longer M2 bolts, right? These are M2 by 12s. So now that sensor is mounted there on the frame part. All right. Coming back to this main base, we're going to mount the the main battery holder. This battery holds two 18650 batteries. It's a nice standard rechargeable battery. They hold a lot of power. I recommend you get yourself a little plastic holder to carry your 18650s around in like this, because you don't want these babies shorting in your pocket or somewhere you throw it in a metal case and these short out. Bad things happen. This is the battery housing for those 18650s. I wish this cable here was a little thicker than this. I would use this housing on more projects. The 18650s can put out a lot more power than these wires can handle. In this robot, it's not a problem. This robot's not going to pull more power, but I just have to kind of know that. But I would use this particular inexpensive housing on more projects if it had a thicker wire here. So this harness is a special battery harness for this project. There's another video on assembling it together, so you can watch that video on how the pieces are soldered together. The important part here is it's got a battery harness, our main on-off switch for the robot, a voltage regulator to take our battery power, which ranges from two 18650s, goes from roughly 8 volts down to 6 volts, which is a 7 volt nominal. This little voltage regulator inside there basically goes down to a nice constant 5 volts for the Raspberry Pi. This other voltage regulator also goes down to 5 volts. This is what we're powering the main servos with, as opposed to using the voltage regulator built into the Arduino, which is not recommended. The voltage regulator built into the Arduino is not as beefy. You can just look at the size of this thing, right? This is going to hold more power. This is rated at 3 amps, and it really can do 3 amps. So just if all the motor seize up or something, this will be okay. This is also rated at 3 amps, but I think there's really only peak at 3 amps. The Raspberry Pi shouldn't pull that on a consistent basis, at least not the way we're using it. So we use this smaller voltage regulator for the Raspberry Pi. All right. So we're going to go ahead and mount this battery. Mounts upside down. Right. So this is the top where the boards mount. This is the bottom where the batteries mount, and the power comes out the back side, right? As opposed to these mounts are on the front side. All right. And I'm just going to use two M2 by 6 to mount this in here. Just kind of put that fingernail tight in there. You notice I didn't put a screwdriver on this end. I keep pulling this nut head through this plastic when I do it super tight, so it's still very secure. It's not going anywhere. Okay, so that's all of the mounting. We're going to start putting the frame together now. So back to the old technique we had before, we're going to use our M3 nuts and M3 bolts that would hold most of the frame together. We're going to use blue tape to tape all of these little nuts in place. Again, I have used nylon nuts as opposed to metal nuts because they tend to hold better. They don't vibrate loose like the metal nuts as easily. So that way I don't have to put blue Loctite on every single one of these nuts in the whole robot. And the nylon nuts cost about the same as the metal ones. So there's a whole bunch of nuts in all these frame pieces. So I'm going to go ahead and use blue tape to put them all in at this point. Right, another thing we're going to mount before we start putting it together is the actual Arduino board. We have the small Arduino Nano here, and it just fits over top of the frame like this, with the headers poking through so we can connect all our cables on from the inside and reach it from the outside with our USB port. There's a little 3D printed part here called the Arduino mount in the 3D printed parts, and it just holds the Arduino on like that. And we use 2 of our 12 mil bolts to hold it on. All right, so now the Arduino board's mounted, our sensor's mounted, our battery harness is mounted. We mounted the horn for the neck earlier. We have all the little bolt holes. Oop, I missed one set. The little nuts in our bolt holes. So we have, now we have little bolts, blue tape held in on all of the frame parts that have them. Some of the parts don't have any bolts in there, particularly the Arduino mount, just because it wouldn't fit, and a couple other frame parts because it wasn't really necessary on all of the frame parts. So I am going to start with one side. It doesn't particularly matter which side you start with, but I'm going to start with the higher numbers, 7, 8, 9, or the left side of the robot. And I'm going to start putting the pieces in place, the cross pieces. It doesn't really matter what order we go in, but just they matter where they go. If you find yourself where one of the nuts, the blue tape, is not on the outside of the robot, switch your blue tape around. So you can see the blue tape is on the bottom where this battery holder is, which will be the bottom of the robot, as opposed to up inside, which would be really hard to get at once we've got the robot assembled. So I'm only putting, but I am going to put all of the M3 bolts on this hole, down this whole side for all these pieces. Again, tight, but not too tight to crack the acrylic. So the battery piece is on the bottom. The neck mount that we mounted the motor on mounts up front, right there. Most of these will only fit in one spot, but best to pay attention to this video where I'm mounting these frame parts. The distance sensor is underneath the neck. It's sort of pointing to the ground in front of the robot. This piece is up in the front. The Raspberry Pi will mount on there, so I call it the Raspberry Pi holder. This is just a stiffener in the middle. Make sure your blue tape is facing up. All right, I got a lot of wires starting to hang off of this. This is the main speaker mount. It goes up here. If you remember the extra piece we glued to the side of the frame, it now lines up nicely with the hole for that speaker mount. Right? And of course I forgot to put in the bolt here because it's on a different frame. I'm just gonna, sorry, this nut. So I'm gonna just slide this nut into place. So now I've got all of the cross pieces of the frame that mount without the bolts. So I'm actually going to start laying wires in here now because it's easier to get it to this open side of the robot. So I'm going to start routing all the wires at this point. So first thing I'm going to do is take these motor wires here and run them up through this hole in the center. Make that a little tidier. I'm just going to move these motors for the back wires off to the side. We're going to get to those quite a bit later. For the Intellisaurus, we've made 3 special wiring harnesses. One for the battery and power with the battery switch and the 2 voltage regulators in it. One wire harness is this I2C bus. Really, there's a connector to the Arduino board, and then there's the connector to the servo controller board, and then the LMU, or the gyroscope board, all run on the I2C bus. The Arduino talks to those 2 boards on the I2C bus. So I had to put this splicer in there just to connect to those 2 boards, right? There is another video on making this cable. Another special cable is this cable to go from the Raspberry Pi to the Arduino. It's just a single line, and I'll talk about that again more later, why I didn't use the I2C bus to connect to the Raspberry Pi from the Arduino, or any of the other multitude of buses that you can connect between a Raspberry Pi and Arduino. There are good reasons in this robot why I didn't use any of those. So this is just a single GPIO line that we use to communicate from the Raspberry Pi to the Arduino. All right, so let's start running these wires. The first thing I'm going to do is slide the power switch up into this top line here. This the power fits in this little slot up there. I'm sliding those cables through the groove, and then pushing the power down. And you want to be careful when you do this. The acrylic is really brittle, and so it's easy to break the acrylic while you're sliding this in there. So just be careful and do it. It's a tight fit, but it should fit nice and snug and not too hard. There, so it's a nice snug fit, but it shouldn't break the acrylic. Okay, so now your power switch is mounted. This voltage regulator here will go to the servo controller, which mounts in the middle, so I'm just going to kind of tuck it underneath these servos right there. This power switch here will come up to the Arduino, which is in the back, so I'm going to kind of leave it coming up the middle here. This power goes to the Raspberry Pi, which mounts up here, so we're going to run it underneath. We're going to run it up through this nice hole here. Run that up through the hole there, and then leave it. It's going to connect to the Raspberry Pis, which will go there for Raspberry Pi. All right. Next, we have the actual Raspberry Pi signal cable. This yellow, they call it a groove connector, goes to the seed audio board. It's a seed audio board connector. They call it the groove connector, and that goes on the Raspberry Pi. So I'm going to feed it the same way up through the center of this hole. It's just going to kind of lie on the bottom of the robot, and then come up between these two servos, and the Arduino mounts back here. Just hold that up so you can see it. So the Arduino mounts here, so we want all those wires coming back to the Arduino. All right. This is just a straight signal cable for the sensor on the front of the robot, so I'm going to route that through. Just make sure you chose a different color cable than the Arduino communication cable, because once this is all wired, you won't be able to trace them back easily. So I just know that my sensor is purple, my Arduino is blue, right? And I'm running it similarly through the bottom, so it kind of lies along the bottom. And then, like this other communication cable, comes up through between these two servos, and then connects to the Arduino. So I got a piece of tape to hold those wires in place. I have another set of wires. This is again my I2C bus. So it will lie here in the middle. And likewise come up between these two servos over the top. And held temporarily in place by my tape. So this sensor down here needs power, and we're going to pull power off of the servo controller board because it has some extra power to spare. So we're going to pull power off of that. Likewise, I need power for the IR sensor, so I'm going to do the same thing. I'm going to come to the middle. All right, it's a lot of wires for one little robot. So let's start mounting some boards. We're going to first mount the servo controller board. It's controlled by I2C, and all the servos connect to this controller. You can see there's little numbers there. So when we labeled the servo numbers, we want to make sure that the wires for the servos that we labeled go to the correct pins. That's how the software knows it's controlling the correct motor. All right. Now the first thing I'm going to do is connect power. So if you remember this connector down here, this power supply or voltage regulator is for the servos. So it has a little power mount here. Making extra sure you get the positive on the positive side and the negative on the negative side. So my servo board is mounted. This is the LMU, or MPU, sorry, or the gyroscope and accelerometer, also controlled by I2C, and this guy is going to mount right in the middle here. I'm going to crank down these. I'm going to hold with the needle nose, my standoffs, and crank down on these. All right, I've mounted my MPU nice and steady so it doesn't move much. It doesn't move while the robot moves around, so it can measure the motion well. Okay, so we've got all the wires run through the body of the robot, and we're ready to put the other side on. The thing to note, of course, is that the other servos are going to come almost right up against these. You can fit one wire in between the two servos, but not a whole lot more, so you might want to move those out of the way in whatever way is necessary. So I get those out of the way. Over here is really where it matters. You just want most of these wires moved in between the two servos. So we've got most of the wires run. We still have to run this tail motor. So this is the small motor to the tail. It mounts here with the circle going to the back. I'm going to put the bolt on the far side first. Could have done that earlier, but. So then I'm going to run the wire below these two servos here, and it's going to connect to the servo board there. Should be just fine coming up like that. All right. Now I'm going to go ahead and put the other side on. I've got all my wires run. The first thing I'm going to do is take these two front motors and feed them through this hole here that I've fed the other front motor wires through, and all the other wires sort of come up to the front of the robot. Now the back two motors here, I can just pull through the speaker hole just to sort of keep them tucked away for now. And there's a bunch of wires coming through this hole in the front center that tends to be a choke point, so I'm going to try and keep those tight as I set that down. Now I'm going to work putting all the little pieces in their slots. I'm going to work from the front of the robot towards the back. I need to put this piece in. This piece doesn't have any screws on it or bolts on it, but it only fits one way. There's a small tab and a large tab. Set that in there. All right, so I've got all the tabs on this front section of the robot here worked in. I don't really have the back done yet, but you'll see the front keeps popping out. So I'm going to put a couple of bolts in here loosely just to hold those in place while I work towards the back of the robot. I'm going to double check down in here to make sure there's no wires. The spacing between these two servos is pretty tight, so I want all the wires sort of in this spacing here, which is pretty wide. And it looks like they are. Now I'm going to start working together the back pieces. Before I do that, I have this piece which fits here behind the battery holder. It's a small little piece. It fits in this way. to cover it should end up being flush with the bottom of the battery holder. There's also the Arduino holder. So the Arduino goes on the back of the robot here in those two slots. So it's kind of all sitting there while I work it. Looks like everything is together. I'm going to put a couple more bolts in to hold it loosely. I've got a few bolts in holding it loosely together, but I just want to double check that all my wires are going the way I want them to, right? I've got all my servo wires sort of coming out, all the back servo wires coming out through the speaker holder there, all the front servo wires coming out this hole here, along with a few wires for the Raspberry Pi. I've got my I2C wires coming up for these two boards. There's a power cable and the other power cable all coming into the center there. And then all of these wires that go to this Arduino are coming up the back there. So I like the way that looks. Kind of tidy. All right, so I'm going to go ahead and put the rest of the bolts on this side and tighten them down. There we go. So I've got all of the wires run. They're kind of dangling. They're not connected, but they're all run in the robot, and the body of the robot is secure. I'm going to go ahead and tape the blue tape off my little bolts now. That is a whole lot easier to do with a pair of tweezers. I've got a pair of tweezers to take the blue tape off with. Remember, I left most of the blue tape off, facing the outside of the robot. Okay, so I've got all the blue tape off. The body is all put together. The bolts are secure. This is the first time we can actually set our robot on the stand. So there are these little grooves right here, if you can see them. And there's a little notch in the back right here. So those fit. There's this whole bar here. And this bar in the back behind the battery should fit on those two grooves nicely. Just kind of slide it until it fits in place. That way you know you're in the right position on the stand. So in the next video, we're going to go ahead and connect all these wires and turn it on.